So welcome guys, in this video we will discuss a dynamic programming problem where we are asked to find the number of bit strings of a given length without any consecutive ones. Just for example, if we are given length equals to 2, so for length equals to 2 we can have byte strings as 0 0 0 1 1 0 1 1. These are the four possible bit strings. So 0 0 is valid, 0 1 is valid, 1 0 is valid as they don't have any consecutive ones. But if you see the fourth one, this is invalid because we have a consecutive one here. So for length equals to 2, our answer will be 3, that we have 3 bit strings of length equals to 2 where we don't have any consecutive ones. So next thing to observe here, that strings ending with 0, we have two strings, that is 0 0 1 0. Then strings ending with 1, we have only one, that is 0 1. Now just record these facts. Number of strings ending with 0 for length equals to 2, that is 2 of them. Number of strings ending with 1 is equals to 1 for length equals to 2. So we have total 3 strings, 2 of them are ending with 0, 1 is ending with 1. Now similarly, I can proceed with this data for length equals to 2 to make these strings for length equals to 3. For example, I'll be adding bits to this valid strings of length equals to 2 to make a string of length equals to 3. So for L equals to 3, now few things which you have to observe here, like ending with 0, then we'll categorize ending with 1. Now we have two strings valid here, that is ending with 0, that is 0 0 and 1 0. Can we add 0 to these strings? Will it be valid? Yes, we can, because by adding 0 we don't get any condition of consecutive ones. Then we have a string that is ending with 1. Can we add 0? Yes, we can. Again, now we'll make a string of length equals to 3 ending with 1. So first we'll take this string's length equals to 2 ending with 0. So can we add 1? Yes, we can. Now we'll take ending with 1. Now can I add 1? No, because here it will break the condition which we need to follow, that is there shouldn't be any consecutive one. So there are two rules which we need to follow. We can add 0 to both type of strings. That is ending with 1 and ending with 0. Second one, we can add 1 to only strings ending with 0. Simple. Now for length equals to 3, if I ask you number of strings ending with 0, that should be equal to number of strings ending with 0 for L equals to 2 plus number of strings ending with L equals to 1. L equals to a number of strings ending with 1 for L equals to 2, because we can add 0 to both such strings. Simple. So we'll have number of strings ending with 0 for length 2 plus number of strings ending with 1 for length 2. After that we have number of strings ending with 1. Again for length equals to 3. So this is simply equals to number of strings ending with 0 for length 2. We have just formulated these 2 points in terms of formula. Now, so simple, we can also see here number of strings ending with 2 is ending with 0 is 2 and ending with 1 is 1. So we have 3 valid strings that is ending with 0, and we have 2 valid strings ending with 1 because number of strings ending with 0 is 2. So let us formulate it. We can say that number of strings ending with 0 for length n is equals to number of strings ending with 0 for length n minus 1 plus number of strings ending with 1 for length n minus 1, because we can add 0 to both these strings. Now, number of strings ending with 1 for length n is equals to number of strings ending with 0 for length n minus 1. So these are the only two conditions on which our complete question is based. So now what we'll do, as every DP problem, we'll make two tables. One will keep the record of numbers ending with zeros. The other one will keep the record of number of strings ending with ones. Simple. Now this index will represent the length of the string. Like the first index will save the answer for length 1, then 2, then 3, then 4, then 5. So we'll by default save 1 1 in the first index, because there can be only one possible string ending with 0, that is 0 itself. There can be only one possible string ending with 1, that is 1 itself. Now whenever I am telling string, I mean valid string. We are only considering the strings where there is no consecutive ones. Now for 2, number of strings ending with 0 for 2 will be sum of both this, because we can add 0 to all the strings that is ending with either 0 or 1 for length equals to 1. So we'll add both this will be 2. But the number of strings ending with 1 for length equals to 2 will be same as this one. That is the number of strings ending with 0 for n equals to 1. So here comes 1. Again for this 3, we'll consider both both the numbers, that is 2 plus 1, that is 3. And for ending with 1, we'll consider only this one, it's 2. Now again for 4, we'll consider both this comes as 5. Here we'll consider only this, that is 3. Here we'll consider both this, that is 8, but here we'll consider only this, 5. So at any point if I am asked that what is the number of valid strings, so it will be simply the sum of this, because I have 3 valid strings that is ending with 0 and 2 valid strings that is ending with 1. So all total I have 5 valid strings. So simple, number of valid strings equals to number of valid strings ending with 0 plus number of valid strings ending with 1. Simple. That's all for this video. Thank you guys.